Let us look at the pedal equation of a circle. So let's first of all draw the circle. Let's take a point on that circle, C. Let's draw a tangent at C. O is the pole or the center. Now, from O, let's draw a perpendicular to the tangent and mark the intersection of the tangent and the perpendicular as A. Now, let's draw these lines. AO, let's mark it as P, and AC, let's draw the line. The idea is I want to remove this perpendicular lines and the tangent. Okay, so just remember AC is the tangent and OA is perpendicular to the tangent. Now let's also bring in the radius vector. So now OAC is a right angle triangle. Okay. Now what the pedal equation is talking of is that as we move the point C around the circle, the tangent and the perpendiculars are also going to move. Then in that case, their intersection is going to also move and form some kind of a figure. So let's see how it will look like. So here, the heart-shaped figure that you see is the graph of the pedal equation. And we have to arrive at the expression for that pedal graph. So let's see how we can arrive at that. Now remember, this is angle beta, angle between the radius vector and the tangent, and this is theta, the angle between the radius vector and the x-axis. Okay, so now we have that. So let's begin. We have already seen tan beta is equal to r d theta by dr. E is equal to r sine beta. Remember, this is angle beta. So sine beta is equal to opposite side by the hypotenuse. So that is how we get P is equal to r sine beta. Now, how to get this equation of that heart-shaped figure is to eliminate theta and beta to get the PR equation. So now what we are going to do is take a general form of the equation. R to the power of m equal to a to the power of m times cos m theta. Now this would be a circle when m is equal to 1. So that means r is equal to a cos theta is the equation of the circle. So now using logarithms, we are going to manipulate this equation. So m natural log of r is equal to m natural log of a plus natural log of cos m theta. So we are taking the natural log of all the terms. Now we differentiate this. M times derivative of natural log is 1 by. So 1 by r times, now we have to differentiate r. So dr by d theta is equal to, m is constant, a is constant. That means its natural log will also be constant. So 0 plus. Now natural log derivative is 1 by. So 1 by cos m theta times, now we have to differentiate cos m theta, which gives us minus sin m theta. Now we have to differentiate m theta. So m. And simplifying this, we get m times 1 by r times dr by d theta is equal to minus m times tan m theta. Taking the reciprocal, first of all, we cancel off m. Then reciprocal would be r times d theta by dr is equal to minus cot m theta. Okay. Now since we know that r d theta by dr is equal to tan beta, we can say tan beta is equal to minus cot m theta. Minus cot m theta is equal to tan pi by 2 plus m theta. So tan beta is equal to tan pi by 2 plus m theta. Since both sides we have tan, that means the angles will be equal. So beta is equal to pi by 2 plus m times theta. P is equal to r sine beta. We have already seen that. So P is equal to r times sine pi by 2 plus m theta, because beta is equal to pi by 2 plus m theta. P is equal to r times cos m theta, because sine pi by 2 plus x is equal to cos x. Cos m theta is equal to P by r. Let's again bring back that our original equation or original curve. R to the power of m is equal to a to the power of m times cos m theta, which means cos m theta is equal to r to the power of m by a to the power of m, which means P by r, because cos m theta is P by r. P by r is equal to r to the power of m by a to the power of m. Means if we take r to this side, it becomes r to the power of m times r, which is r to the power of m plus 1 is equal to a to the power of m, the other side, times p. So this is the pedal equation of the curve defined by r to the power of m equal to a to the power of m times cos m. So let me just demonstrate this to you again. So now again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.